Okay, so there's the homework answers here. And now we're going to turn our attention over to the notes for today, which are here. Okay, so these notes, we're going to just let me make sure that that continued to record properly. There we go. Okay. Hopefully, yep, the voice is coming through. Good. Okay. So, let's go back over here to this. All right. So we're going to talk today about a couple things. First of all, we're going to talk about something called resonance. So when we are looking at certain structures, they can be drawn a couple different ways. So for example, on your homework tonight, or last night, you had nitrate drawn, right? You could have drawn nitrate. Oops, doesn't need those. You could have drawn nitrate with the double bond here, okay? Or you could have drawn the nitrate with the double bond here, or you could have drawn it with the double bond here, okay? All of those structures would be correct, but they all are actually correct. What's happening is that bond is kind of moving between these three locations. And that's known as resonance. So here's another example down below with ozone, okay? Ozone could be drawn with the double bond here, or it could be done with the double bond here. And you use an arrow to show that it kind of moves back and forth between these two structures. Make sense? All right. So then the second thing that we're going to talk about today. So resonance was one. Bond length is a second thing. Bond length, the way you do that is you count the number of bonds. So here we have 1, 2, 3 bonds. And you divide by the number of bond sites. So 1, 2. So 3 divided by 2 is 1.5. Okay. If you're looking at the nitrate again, if we wanted to draw that back up here, its number of bonds is how many? 4. How many bond sites? 3. So, oops, my line in the wrong spot. Sorry. 4 divided by 3 is what? You could do this in your head. 1.33 repeating. Okay. Good. All right. So that was 2 things that we're going to talk about today. And the third thing we're going to talk about today is something called formal charge. And that's going to take us a little bit longer to get through. All right. Formal charge. Now, if you go out and you go onto YouTube, there's a bunch of different ways that you can do formal charge. Okay. There's very, very complicated ways, and that's typically the way most people teach it. But the way I teach it, it's very easy, I think. Okay. It comes down to something called should minus has. When multiple structures are possible, we're going to use formal charge to determine which one is best. Okay. We're going to calculate formal charge using should minus has. The should is the number of valence electrons that an atom should have off the periodic table. So this is the counting of the periodic table. 1, 2, skip the D block, 3, 4, 5, on to 8. Does that make sense? So that's your should. Your has is how many electrons are directly attached to the atom. So here, this is the one kicker that gets people in this method. Okay, but trust me, it's much easier than the other options. Here, instead of a line between atoms counting as 2 electrons, and this is the only time you do this, is when you're doing formal charge. Only time. That line is going to be 1 electron. All right. So let's do some practice here with these. Keep in mind that the best structure is the one where you have 0 formal charge on everything. If you have to put a formal charge on something, it has to go on the most electronegative element. Okay? So remember when I asked you at the beginning of class if anybody had the SO3 drawn differently, and if you had it drawn like this, and how I told you that that was wrong, but there was no way for you to know that it was wrong because you hadn't been taught formal charge yet. So let's figure out the formal charge on this. Okay, and then we'll go back and look at my structure. So how many electrons should sulfur have? Off the periodic table, how many valence electrons should sulfur have? 6. Now, remember, when we're calculating formal charge, and this is the only time that these count as 1, these lines count as 1 electron. So how many do we have around sulfur? 4. So 6 minus 4 is 2. Our oxygen should have 6. Anybody not know where we're getting this 6 from? It has 1, 2, 3, 4, 5, 6. So 6 minus 6 is 0. Here, oxygen again should have 6. How many does this one have? 7. So it's a -1. And this one should have 6. It has 7. So it's a -1. Okay. Now our overall charge on the whole thing is 0. But we still have formal charges on these atoms. Now let's go back and look at the way I had mine drawn with the expanded octet. This is the way I had it drawn. Oxygen again should have 6. It has how many? 6. So it is 0. And that's going to be true for this one and this one because they're all the same structure. So this one's a 0 and this one's a 0. My sulfur should have 6. It has how many? 6. So this is the preferred structure here because there's no formal charge on any of the elements. Okay. But again, there was no way for you guys to know about this because I had not taught you formal charge yet. So don't feel bad about it. All right. Let's figure out what our bond length is for this guy. How many bonds do I have? 6 divided by how many bond sites? 3. So its bond length is 2. Good? All right. So here we have this one drawn. This one is not drawn properly, though, because our carbon doesn't have a full octet. So we're going to redraw this so that carbon has a full octet. And it has a charge of -2. All right. So this is the proper structure for this. We need to check our formal charges on this now to make sure. The other thing is that this could be a resonance structure as well, because that double bond could be here or it could be here. So this has 3 possible resonance structures for it. All right, so should minus has. Oxygen should have 6. It has how many? 7. So its formal charge is a -1. And this guy is going to be the same thing because it's the same exact drawing. Here it should have 6. It has how many? 6. So it's 0. Carbon should have 4. And it has 4. So it is at a 0. Our overall charge here is a -2, which syncs up or checks out with the charge that's written out here. Okay. Questions on that guy? What is my bond length here? How many bonds? 1.33. Yep, we've got 4 bonds. We have 3 bond sites. And that's a 1.3 repeating. Okay. All right. So you've got these structures drawn. See if you can figure out the formal charge on each of these atoms. And then see if you can figure out what the preferred structure would be. Give you a minute or two to work on that. Okay there, kiddo? All right. All right. Need more time? Need another minute? Okay. All right, so nitrogen should have how many? 5. Carbon should have how many? 4. And sulfur should have how many? All right, so this nitrogen has how many? 7, so it's at a -2. This carbon has how many? 4, so it's at a 0. And the sulfur has 1, 2, 3, 4, 5. So it has a -1. Okay, over here, how many does this nitrogen have? 1, 2, 3, 4, 5, 6, right? So it's at a -1. Our carbons has how many? 4, so it's at a 0. And our sulfur has how many? 6. Okay, so it's at a 0. Nitrogen here has how many? 5. Carbon has 4. And sulfur has 7. Okay, oops. Messed that up, sorry. There we go. -1. Okay. So when we're trying to figure out which structure is preferred, if we can build a structure with as few of many formal charges as possible, that's what we want. So we're going to get rid of this guy automatically because we had formal charges on 2 atoms. We have 2 options here where we can have a formal charge on just 1. Okay, so this one's quick to eliminate. Now we've got to toggle back and forth which one of these is right. Well, when you are doing these, if you have a formal charge, it must be on the most electronegative element. So is nitrogen more electronegative or is sulfur? Remember when you did your chart as we went up, your most electronegative elements are fluorine, oxygen, and nitrogen. I'll tell you that. So sulfur is less electronegative. So that means that this is our preferred structure because the formal charge is on the more electronegative element. All right, so try the next one. See if you can figure out what the preferred structure is between these 2. These 2 were proposed. What's the preferred structure? Need another minute? Doing okay? All right, so hydrogen should have 1. It has 1, so its formal charge is 0. Carbon should have 4. How many does it have? 4, so it is at 0. Oxygen should have 6. It has 6, so it is at 0. Over here, 1 minus 1 is 0. This carbon should have 4. How many does it have? 5, so it's at a -1. This oxygen should have 6. It has 5, so it's at a +1, and then the hydrogen's at 0 again. So here, when we built this one, this structure has formal charges. This one has no formal charges. This is going to be preferred. Even if we did this one, it would still be wrong because your negative value has to be on your more electronegative element, which in this case is oxygen. So because of that alone, this guy's out. But if we can build it without any formal charges, that's what we want to do. Okay. Going back to this guy, what is my bond length on this? How many bonds do I have? 4. How many bond sites? So my bond length is 1.3 repeating. All right, nitrate is NO3 with a -1 charge. So I want the structure drawn, and I want all possible resonance structures. So I want resonance drawn on here, and I want a new bond length. So I want the structure, the resonance, and the bond length for this guy. Oh. Yeah, just take a pass. No, you're supposed to take the regular pass. I don't really care. Don't yell at me. I'm used to it. Just a secretary that yelled at me. It wasn't like an admin. Just don't go to the main office. And we're good. That's where I got caught. All right, you ready to try this one? Or are you still working on it? Okay, so all possible resonance structures, you have your nitrogen here. You would have an oxygen drawn here, possibly. And then this guy here, and then your oxygen over here. And then you've got your formal charge of -1 here. And if we're drawing all formal or all resonance structures, you could also draw this with the double bond here with your oxygen. And we draw arrows to show that these can go between these structures. And I had it there, so it needs to go down here now. And here, and then I'm going to draw my arrows here. Okay. And then my resonance structures are drawn. My bond length would be what? 1.33 repeating. And that means that, that I got that because I had 4 bonds over 3 bond sites. Good? Did you do okay? All right. And formal charge, determine the formal charge of hydroxide here. So if you can figure that out. All right, hydroxide. It's OH. We found that on your sheet. You're going to have your oxygen here. Hydroxide is OH minus. So this is oxygen has 6, hydrogen has 1, and then we have this extra one. That gives us 8 total electrons in play. Right now I have 2, 4, 6. So oxygen's going to get the other 2 over here. I need to bracket this in, and I need to put a minus here. For my oxygen, it should have 6. It has 7. So that's a -1 here. Out of myself. This is a -1. And then your hydrogen has 1. It should have 1. So it's a 0. Should minus has. This formal charge then should add up to be the same value as the charge on the ion. That guy. All right. So when you're doing these, you need to make sure that you have the least electronegative element in the center. Hydrogen always goes on the end. You want to make sure that you have a complete octet, except for hydrogen, of course, because it's a duet. You want to have your electrons where you've got those paired up at least, and then your formal charge should minus has. All right, so try to draw this guy keeping these things in mind. All right, I got my carbons here. These are my 2 carbons. Remember, hydrogen always has to be on the outside. And then I've got my hydrogens built in. We're going to count our electrons and make sure that, that they look good. We have 4, so this is 8. 8 plus 6 is 14 electrons that we need to place. We have 2, 4, 6, 8, 10, 12, 14. So we've got that checked off. We can check off our octets and make sure that they look good. This has 8 and this has 8, so we're good there. And then if we check our formal charge, our hydrogens are at 0 and our carbons are 4 minus 4. That gives it 0. Our formal charge checks out as well. Okay? See if you can draw this guy. Eight and 4 is 12 electrons. So on this one, I have 12 electrons to place. How many do I have placed right now? 10. Hydrogens can't take anymore. Carbons, I could put one here and one here, but that doesn't work because then this would have 2, 4, 6, 7. So that doesn't work. What am I going to do, Aiden? Yep, I'm going to double bond here. That's going to complete my octet for both of my carbons. Both of my hydrogens will be good. And I have 12 electrons placed. Now I'm going to go back and check my formal charge. Hydrogens are 1 each. Or 0, I mean, 0 formal charge. 1 minus 1 is 0. And then my carbons, I should have 4. And I have 4. So my formal charge is taken care of there as well. Okay. And then here's the last one. This is carbon and nitrogen coming together. So see if you can figure that out. Remember, we do have a -1 here. For its charge. So electrons, 4 and 5 is 9. So 10 electrons here. All right, so my carbon is sitting here like this. I have my electrons here. And what I need to do is I need to bring in this electron into here and this electron into here. That's going to make a double bond. That's taken care of. I have 10 electrons, so that's 2, 4, 6, 8, 9. Oh, did I take it wrong? Did I pull off too many? Oh, I had an extra electron. I forgot to put that guy in there. Okay. So here. So then if I take these 2 electrons here and bring them to here, that's going to give me a triple bond. And then I'm going to just pair these up nicely so that they're together because we want lone pairs. They like to sit together. Okay. Now, I need to have square brackets around this. Did anybody have anything different that they drew? We all came up with the same thing? All right. So homework tonight then. I think that was the last of the problems, right? That must have been it. Okay. So homework tonight is 8-4. And that's due tomorrow. Good? Questions? All right.